Don't mind the air gap. What it is all about. First of all, terminology. My talk is called Maximizing Exfiltration Speeds over HDMI TEMPEST, and I made it up so that I would sound smart. And yes, let's start with HDMI. This is the DisplayPort connection, or display connection, let's be more specific, that my laptop is also connected to. It's very common. Tempest means some kind of unintended radio emanations from electrical devices that can be used for nefarious purposes. And air gap, here with air gap, I just mean that, there is a literal air gap. We don't have a cable, or we don't even have a radio connection to the device, the target device. And exfiltration, it means secretly transmitting information out of some system. So what is the combination? What is going to be expected? I will first give some background about what is it about HDMI that makes it vulnerable to Tempest. And I'll then tell you how I designed low-level protocol, let's say, unidirectional protocol to transmit information using this vulnerability. We'll discuss some results, how far can I make this connection, and how fast it can transmit bits. And finally, I'll discuss some practical applications, maybe nefarious or not, and then let's discuss what could be better about this and how you could be protected from it. Who am I? I'm a software developer as a profession. I mostly I've been writing stuff related to real-time systems and networks on the OSC layer 1 especially, and yeah, C++ stuff. But at nighttime, I sometimes investigate mysteries, especially related to signals, and that's what I enjoy. I write a blog about it in this address. And yeah, that's all about me. So I would like to begin with a story. How did I end up researching this thing? So I was listening to some radio broadcast. I was supposed to blank all of these bookmarks here, but please don't look at them. And on some frequencies that I like to listen to, there was some kind of noise. It was really irritating me. And I wanted to find out why this happens. And it always happens at my home. So it must come from some of my devices, probably. And I listened to this, because in this software you can listen to anything. And it kind of sounded like, you know, if you're old enough to have had the 8-bit Nintendo as a child, it has 2 ports for audio and video. And especially for a child, it's very easy to mistake one for the other. So sometimes I would actually plug the audio cable that goes into our stereo to this video socket. And there was a very, let's say, the sound was very similar to this one. So I was kind of wondering, could this be video? But why on earth would there be video at my home? Video transmission? Is there a camera somewhere? Maybe. Unfortunately, what I had audio here, but we had some technical issues with the HDMI connection that was supposed to play the audio. So unfortunately, there is no audio now, but you can imagine kind of a zzz sound. OK. Whoa, it played, actually. I guess if you play it without sound, it kind of goes as fast as the processor can take. So I made a plot, a 2-dimensional plot of this signal. Here on the right side, you see kind of the voltage level of the signal. And so the voltage is the vertical axis, and the time is then horizontal axis. And on the left, you can see kind of a Fourier transform of the frequencies. And this happened to be exactly 60 hertz. So yes, it does indeed sound like some kind of a video signal. Maybe these peaks could be the frame start because they happen once every 60th of a second. And then in between this very low-level noise, maybe it is the video. And what happened was so I took all of those little noisy things, and I took the amplitude of those samples, and I plotted it as an image. And indeed, it looks like one of my computer's desktops. So this is actually a very old thing. It has been known for at least 20 years. There is this paper that I always refer to by Markus Kuhn. So actually, it was even before HDMI. It was before digital displays even. All kind of the displays emanate some sort of signals that have a correlation to what is on the screen. But HDMI is digital, so how can you see that with like an analog kind of receiver? I'm sorry about the next slide. I just got really carried away with Blender, but I wanted to show that it's very complicated how HDMI encodes the colors to these 10-bit characters, so there is no clear one-to-one mapping between them. And it kind of does an XOR there, an XNOR there, and it chooses between those and based on some rules, and then it inverts the bits if their statistical properties are not perfect. And we get these 10-bit words. And somehow, each of these 10-bit words has a kind of a different amplitude in the radio. But this is not like a direct mapping. You can't see grayscales. You can't see colors, of course. So what I did, I went through all of the colors. Yes, all of the colors, because my display only has 16-bit colors, so there is 65,000 something colors. And here's a small part of it. And I tested each color, put one scan line of the color, and see what kind of amplitude we get. And with this method, I was kind of able to encode my own kind of images, basically to make grayscale transmissions using this thing. We have a little demo video here, but it goes by way too quickly for some reason. Technical issues. Uh-oh. Just a minute. I really want to play this video, but anyway. Let's see if this fast forward looks like anything. Oh, perfect. Thank you, HDMI. I have the display running on the left here, and I'm using my color map that I just showed to basically send like 1-bit animation over this air, basically. What I have there is my directional antenna, and you see when I'm turning it around, the colors kind of invert, so it's not even very stable, the mapping. It depends on many things. I don't even know what it depends on. But how could we use this for transmitting something ourselves? I mean, this is just some very noisy, distorted stuff. Could we make some sort of protocol that we would use the colors to transmit bits? The problem is that I don't know the absolute amplitude, what it's supposed to be. What I came up with was I could have two stripes on the screen, and the difference in amplitude between one and the other stripe would mark bits. And yeah, this seems to work. I did it vertically because in the horizontal direction there is some kind of echo and some low-pass filtering. I guess my radio isn't that good, so I thought maybe the vertical direction would be better, and it actually is. On top of this basic, simple, one-bit thing, I started building like a protocol. Whoops. So I want to have it error protected so that it's reliable. We can send reliable information. Let's divide the data into packets first. We could add some header information to these packets, at least the position in the file, so we know where to put it in the final file that we are sending. And of course, because this is a very noisy connection, we want to add some forward error correction. So basically, we just add more bits into the stream so that kind of exchange bandwidth for reliability. Then for each packet, we add a CRC, which is a checksum. With this, we can be sure that the packet was received intact. Then one more thing, we can add a preamble in the beginning so that we know where to start receiving, so where the information starts. And because this is video, we can even repeat every frame to get even more reliability. So if the receiver doesn't get it the first time, it can integrate from 2 frames, and then we get some better signal. It causes some overhead. Here is an illustration of the overhead. But I mean, it's doable. It's doable. So they run from up to down. My display happens to be 768 high, so I made 768 packets, so I can nicely put them next to one another. Here we see what it looks like in real life. This is kind of, I kind of made a bad decision with this vertical thing for many different reasons. One of them is that the cache I get a lot of cache misses when I process this data because the processor has to jump up and down and left to right in the memory. And there's one more kind of an irritating thing. The Raspberry Pi 4 that I was using, it doesn't really play nicely with VSync video, so there is a bad tearing effect. And whenever there is tearing, it always goes straight through the image horizontally and breaks every packet. So I get 0 data at all. So eventually, later, I redesigned it and made it horizontal. But here's how it looks like on my receiver. So I have like a receiver software with this kind of 1980s plasma screen aesthetics. And it's specialized for this purpose. It's running on this little laptop here. It's just a MacBook M1. Pretty much single thread. And I use a small radio receiver called AirSpy. And then this huge antenna that gives me a lot of directionality. And because I got it for free. So what kind of distances can we send these packets? Here, I got carried away with Blender again. Here's my room. I put the receiver on the table at the top. The Raspberry Pi and the HDMI display are in another room behind a closed door. And with this setup, I was able to get 200 kilobits per second using this method. There is, of course, a lot of packet loss, but we can do some tricks to kind of alleviate that. For example, we can repeat things, or we can add more error correction if the packet loss ever gets too bad. So, of course, I got a little obsessed with putting as many bits through as possible. How much can we get? With this vertical setup, I was able to get about half a megabit per second in the same room. Here we have like 3 different kinds of measures for the speed. There's the total speed, which is how many bits my program is reading from the screen, and then how many of those bits are actually from new packets that were never seen before, and then how many of those are something else than CRC or error correction. So that number is half a megabit. But can we get 1 million? Maybe. I applied some optimizations. So first of all, I did the horizontal thing. So packets now run horizontally. We get 1 megabit per second, and now I can give this a name, this protocol. I call it MacFeast, which is megabit connection for exfiltrating all secret tokens. Yes, very useful. Thank you very much. But with all of this, I kind of made a huge assumption. I made the assumption that we already have some kind of way to control what is displayed on the screen. Of course, if it's an air-gapped system, you can't really do that, or can you? I tried to brainstorm some ideas. Maybe you could embed some bits in the raw video files, if it's a system that plays video files. If it's some kind of a system that loads images or textures from disk, such as maybe like an information screen, maybe you could somehow tamper with those. I'm not sure. Maybe you could tamper with the screensaver, because screensavers are known to contain all kinds of wacky graphics, so nobody will bat an eye if there is a little bit of Tempest exfiltration going on. Or maybe the boot splash, because this thing can, in optimal conditions, 1 frame can contain, I would say, 2.5 kilobits or kilobytes per data of data. So you don't need to keep it there very long if you can compress your data very well. And of course, you could maybe come up with some way to access the raw pixels on the screen. But as you saw, the red screen kind of looks pretty conspicuous, let's say. How could we hide it? Well, we could, for example, slightly modify the picture on the screen. For example, here is a familiar picture to some Windows screensaver that has been modified to add about 2 kilobits of this data. If you look very closely, you can see that there is some level of horizontal blur, but it's not very visible from far away. And if you just send it for 1 frame, I mean, it's just another glitch. Nobody cares. What are some applications that we could use this for? File transfer. We could transfer some kind of a file that knows that it has been received completely. For example, zip files, they have their own CRC in the end or in the beginning. But now we come to one of those downsides of this method. There is no return channel. You cannot request packet again if you happen to lose one. So transmitting big files is kind of a difficult thing. You have to wait for the repeat if there is a repeat, and that can take some time. Yeah, packet loss can be difficult to deal with when you have files. Well, what about some streaming data, like audio and video? I mean, audio doesn't need that many bits per second. You can transfer high-quality music at 160 kbps. And video, you would think it needs a lot of bits per second, but does it really? I mean, 500 maybe, you could put some video through. Or you could put some static screenshots. If you're ever taken a look at what the Teams desktop share does in the network, it doesn't use that much bandwidth. I guess there is a pretty good compression for desktop screenshots. And these kind of streaming types of data are pretty forgiving towards packet loss, because you can just ignore it in your mind if one frame is missing or a piece of audio is missing. And indeed, just this morning, I did something related to this. I hope this video doesn't play through in 1 second. It does. I'll start it as many times as... OK, I want to warn you that there is some flickering imagery. So just so you know, here is the display in my room. And here is what I was doing still this morning. We have to tune it to the frequency first and get the PLL right. Hey, look who's there. So this is an MJPEG stream at 2 frames per second, and all error corrected and everything running just from the HDMI cable. Yes, thank you very much. What are some other uses? Maybe keylogger. If we use a huge amount of bits for the error correction and the other stability and other stuff, we could use this for very reliable keylogging. And it doesn't leave a trace, so it doesn't leave a log in the computer. Basically, just could transmit some blip here, maybe even delayed, so the user doesn't see that it's actually logging keys. I came up with one sort of wholesome or good idea. Maybe we could use it to debug games. I mean, every scan line is kind of imprinted with some kind of code. So with the radio, you could see how many of those scan lines end up in wrong frames and if there is issues with the vertical synchronization. As I already discussed, it's not a perfect protocol for transmitting just anything. It's easily broken. Video compression probably breaks it. I haven't tested. Yeah, tearing on Raspberry Pi 4 breaks it. Maybe we even have to know the exact video sort of specifications, the frame rate, even the color space, to be able to reliably choose the colors which we use. But yeah, and the frequency that I'm listening to, it's not even reserved to anything. There could be something else that is not compatible with our reception. So yes, how could we protect ourselves with this sort of attack? Well, HDMI is a pretty old protocol, and already in 2.0, 10 years ago, they added scrambling, which means that they add a pseudo-random sequence of numbers. And this is, like, the primary reason is to minimize electromagnetic interference. And it not only kind of encrypts it, but it also, to my understanding, the whole signal kind of disappears from radio because it loses the repeatability kind of that makes it a signal, basically. And in DisplayPort, this has been a thing since 2006. I also came up with some silly mitigations. What about this? Yeah, it's very impractical, I would say, and also maybe a slight fire hazard, I would imagine. And then somebody told me about chicken wire. Well, what about chicken wire? Well, you can see through it, but I tested this, and there was no effect. No effect. Maybe the cable could be wrapped in tinfoil, and then we could wrap the monitor with chicken wire. Or maybe we could put the user in a cage. I'm not sure. The chicken wire is not grounded, and I was also made aware that this might be a problem with the thing. But this was as far as I was willing to go with chicken wire and electronics at my home. So I was kind of worried of grounding stuff that might be accidentally connected to mains. What are some main takeaways? HDMI 1 is very loud in the radio and kind of insecure if you care about that sort of stuff. But I mean, if you're aware of it, then not a problem. This is somewhat of a surprising side effect. I mean, I wouldn't think that pictures on my screen are transmitted away. But the more you know. We also learned that Raspberry Pi 4 cannot properly do VSync, so I might have to use the previous generation. Yeah, tinfoil hats are really warm. I actually made several pieces of clothing out of tinfoil, and it's really hot. Thank you very much. I finished so fast that I have time for audience questions, and we have a microphone guy there. And yes?
Okay, thanks. Nice talk. Thank you for it. It seems that you made all the tests with the same monitor. Have you tried, like, is it how much it depends on the exact same monitor, or is it how, if you just say change it, is it still like, does it work?
I did this in Disobey 2018. Maybe I came here with a big antenna and I pointed it everywhere, and from everywhere I could like spot another display, another display, another display. If I just used the full HD, because this wasn't full HD, so if I tune it to kind of the full HD frequency, I could find those. So I think pretty much every display is vulnerable.
Thanks. So if you know the scrambler, like whatever random mesh sequence it has, like can you then dig up the signal, like in style of CDMA or something?
I think it's pretty difficult because the scrambling also makes the whole signal disappear because the like repeating structure is lost. So we don't have the, like, this all is based on the pixel clock that we have. For some reason, the pixel clock is radiating very strongly, and we can see the pixel clock in radio, and then this pixel clock is somehow modulated with the brightness.
It has been some days since you posted in the windytan blog. That's fine, but can you indulge us as to what might be the next post about, if any? Or are you still wondering about it?
I have maybe 3 concurrent projects. One of them is this, and maybe I will post something. Who knows? Because I would really like to make like a proper write-up of all of this. And yeah, I have all kinds of, let's just say, using surprising things for networking ideas. Any more questions, or we have a question there?
Have you found out what is the source of the signal leak in the monitor? Is it the monitor itself, cable, combination?
Sorry, I'm not hearing this at all.
Maybe I'll talk louder. Is it better now?
I think the monitors are not on. I'll try this. Try now.
Okay, any better?
Yeah.
Okay, have you found the source of the emission from the monitor? Cable or the monitor itself?
No. So I've tried to wrap either the cable or the display to tinfoil or whatever, but neither of those had any effect. So I don't know where it could be coming from. I heard that there are HDMI cables that somehow use optical fibers.
Oh.
So I might try that next. If I use an optical fiber, it cannot possibly be the cable.
Yeah, if it's really that. But could be also the display card. But
Maybe.
one thing that occurred to my mind is if it's the monitor or if it's the cable, maybe you could, or if somebody is smart enough to write the code, send a screensaver or screen off command at the beginning of the video stream you're trying to pick up. So you could blank the screen before actually transmitting the signal.
That is true. That is true. Yeah.
Yeah,
Thank
thanks.
you. Yes. Should I go? No, actually, here better this way.
Have you tested it with KVM or like, yeah?
No, I've only tested with direct connection from laptop or desktop PC and all of these adapters.
Yeah.
Okay, if that's it, thank you very much. You can always ask me, and thank you.